More than 250 million years ago, Earth had just gone through the most terrifying disaster in its history. The Permian Triassic-Extinction Event, where 90% of marine species and 70% of land species vanished. The planet became a scorched wasteland. Forests burned to ashes, the climate blistering hot, and the oceans drained of life. But right in the middle of that hell, a miraculous story began. Tiny reptiles, seemingly useless, survived and slipped through the cracks of fate. No one knew that they, the weakest creatures of that time, would become the ancestors of the rulers of Earth for more than 135 million years. And did you know that the rise of the very first dinosaurs on Earth began simply with a rainstorm? So what is the truth behind this story? Let's return to the Triassic period where it all started. When the Triassic period first opened, Earth was still engulfed in the aftershocks of the most devastating extinction event ever recorded. Life was nearly wiped out, and the planet became a desolate world where every day felt like living inside a cosmic furnace. The global average temperature rose to unimaginable levels, with some places reaching between 50 and 60 degrees Celsius. The atmosphere thinned, oxygen dropped to around 15%, forcing all surviving organisms to struggle just to breathe. Many scientists describe this era as the Age of Heat, a time when Earth resembled a barren planet more than the home of life. On the surface, deserts stretched endlessly. Scorching sand, toxic winds, and massive dust storms became the new normal. Forests disappeared, leaving only sparse, withered patches of vegetation clinging to survival in the dry climate. Early Triassic geology preserves abundant evidence of this extreme background. Strongly oxidized red beds, massive salt deposits from evaporated lakes and inland seas, and cracked sediment layers typical of a water-starved planet. In many places, volcanic ash and dust accumulated into thick strata, indicating that geological activity remained relentless after the Great Extinction. Towering over the entire landmass was Pangea, the one and only supercontinent, so enormous that its interior lay thousands of kilometers away from the ocean. This created one of the harshest climates Earth has ever experienced. During the day, the ground burned like fire. At night, temperatures could drop to freezing cold. Without oceans to regulate the climate, and without large forests to retain moisture, the entire center of Pangea turned into a vast red desert spanning the size of a modern continent. Only the long coastal strips stretching tens of thousands of kilometers held more abundant life thanks to rivers and thriving vegetation. In this context, life did not completely vanish, but it survived only in its most stubborn forms. Reptiles became the temporarily dominant group, as their bodies were better adapted to high temperatures and arid environments. The ancient relatives of mammals, such as cynodonts, still existed, small and agile, living by hiding in shade and rock crevices. At the same time, primitive crocodile-like reptiles belonging to the crocodile morph group began to flourish. They were opportunistic predators with sharp teeth, low stances, and strong adaptations to semi-arid environments. In the ocean, ecosystems were also slowly rebuilding. Sharks survived but no longer held supreme dominance. Bony fishes began competing fiercely, evolving rapidly in speed and hunting efficiency. Nothosaurus, primitive marine reptiles with flattened bodies and webbed limbs, appeared along Pangea's coasts, forming a new group of predators in the recovering seas. Large amphibians like labyrinthodonts still lingered in some moist regions, but their numbers declined as the environment grew drier. The insect world also witnessed a surprising boom. Primitive crickets, strange roaches, early beetles, ancient locusts, and many mastic-ending species with strong chewing mechanisms thrived thanks to the rebounding plant life. They became crucial links in the recovering food chain, supplying nourishment for small reptiles. Overall, the early Triassic was a chaotic yet full of potential world. It resembled a stage completely burned down, but awaiting small sparks to ignite a brand new performance. But then, In the midst of what seemed like an unchanging era of drought, an unusual event occurred, a phenomenon lasting centuries, even thousands of years. Powerful enough to reshape entire ecosystems and rewrite the evolutionary direction of many species. This event is now known by a familiar name among paleontologists and geologists, the Canyon Rainfall Event. The Canyon Rainfall Event is known primarily through meter-thick sediment layers in the Canyonlands region, now in the state of Utah, United States. There, the characteristic red desert sediments of the Triassic are suddenly interwoven with fine clay layers, gray sandstones, and traces of ancient stream flows, indicating the sustained presence of water. This contradicts completely the extreme climate for which the Triassic is famous. So what caused a land nearly dead and dry to suddenly receive so much rain that rivers, ponds, and wetlands formed? One of the most widely accepted hypotheses is large-scale volcanic activity. After the Permian Extinction, Earth's crust was unstable. Pangea, the massive supercontinent, began developing rifts and intense magma activity. Violent eruptions released enormous amounts of carbon dioxide into the atmosphere, raising the already high greenhouse effect. When the atmosphere reached saturation with water vapor, tropical rains, almost like super monsoons, appeared and persisted for extremely long periods. The semi-desert climate abruptly shifted into an ultra-intense monsoonal system, with rainy seasons lasting for many consecutive years. For the Triassic world, this was a turning point. The dry ground absorbed water and cracked open, giving birth to the first small streams. Low-lying areas became lakes, and ancient valleys started accumulating silt. Seeds of drought-resistant plants waiting for decades in the soil sprouted rapidly. Conifer forests, needle-leaved trees, and low ferns began spreading along newly formed moist belts. If early Triassic Earth was a world of sand and stone, then mid-Triassic Earth became a moment of green awakening. However, this shift did not only bring opportunities, it also triggered a brutal wave of natural selection. Many large reptiles accustomed to dry heat, especially crocodile morphs, began struggling. Their bodies were optimized for water-scarce environments. Sharp teeth for tearing tough flesh, thick skin for sunlight, and heavy builds suited to arid terrain. But as rainfall increased and vegetation changed, new plant life replaced the sparse desert shrubs that small herbivores once depended on. Shifts in food sources led to declining herbivore populations, and as a direct consequence, predators dependent on them faced severe shortages. For small herbivores, once dominant in the early Triassic, the Canyon Rainfall Event acted like a soft but inevitable death sentence. They were adapted to dry landscapes where scattered low shrubs were their primary resource. But when conifer forests expanded with taller and denser plants, the short-bodied herbivores could no longer access their food sources. Their fast growth and low body structure no longer fit the new environment. They were outcompeted by species capable of reaching higher foliage. These changes drove many primitive herbivorous reptile groups to extinction or severe decline. Carnivores dependent on these herbivores fell alongside them. As prey vanished, large and heavy predators were the first to suffer. Giant reptiles like the Erythrosuchidae, once the rulers of the early Triassic, were pushed to the brink of extinction. They were too slow to catch the new prey, too large to adapt to shifting environments, and too reliant on the old food chain. But in the collapse of the old ecosystem, opportunities opened for smaller creatures, those once overlooked during the early Triassic. These were the primitive dinosaurs. As new forests spread, habitats became more diverse. Small bipedal dinosaurs, light-bodied with legs positioned straight beneath them, and efficient breathing systems began to expand. They could run faster, hunt more effectively, endure heat better, and crucially survive in dense vegetation with abundant high-level food layers. The Canyon Rainfall Event did not create dinosaurs, but it erased their competitors and opened a new playing field where dinosaur traits became absolute advantages. From here, the Triassic ecosystem entered a new era. The rains gradually stopped, the climate stabilized, but their consequences lasted for tens of millions of years. The old rulers of the Triassic deserts disappeared, and a new group, agile, intelligent, and resilient, began writing the next chapter in Earth's history. And that turning point, born from endless rains over the canyon lands, is the very reason dinosaurs were given the chance to rise and dominate the planet for more than 135 million years. After the Canyon Rainfall Event passed, the Triassic world was no longer the same. Land once cracked like a turtle shell now hosted new riverbelts, damp valleys, and countless seasonal lakes. Soft plant groups, mosses, ferns, seed plants with slender stems returned after millions of years of destruction. A thin green cloak draped over the brick-red soil of the Triassic, signaling rebirth but also heralding a great terrestrial purge. Before the Canyon Rainfall Event, dinosaurs were underdogs. They were just a small group among countless reptile forms, living in the shadows of beasts like Rainstorms, giant relatives of modern crocodiles, or erythrosuchids, top predators of the early Triassic. Dinosaurs back then were small, slender, quick, but not strong. Their numbers were so low that to the dominant creatures they were nothing but marginal organisms. But after the Canyon Rainfall Event, everything changed. Traits once seen as disadvantages became the keys to survival. Unlike most reptiles of the time, which walked with sprawled limbs, dinosaurs stood upright, legs placed under the body, not splayed to the sides. This gave them three major advantages: long-distance movement with low energy cost, better balance while running fast, and easier adaptation to muddy, slippery ground after the heavy rains. When the environment became wetter and softer, heavy pseudosuchians were easily bogged down. In contrast, dinosaurs, lighter with compact steps and stable bodies, advanced. Dinosaurs soon possessed hollow yet strong bones, similar to modern birds. This helped them run faster, lighten body weight, conserve energy, and expand their ranges. In a world constantly changing, creatures capable of traveling far and seeking new territories survived. Dinosaurs possessed a primitive air sac system that allowed air to flow in one direction through the lungs, enabling oxygen exchange far more efficiently than in most other reptiles. From this trait, they could endure the low oxygen atmosphere characteristic of the Triassic, the hot and humid climate, and long-distance endurance running. While other large creatures were choked in the most literal sense, dinosaurs continued to thrive. Many early dinosaurs were not picky eaters. They consumed young leaves, insects, carrion. This helped them adapt well when Triassic flora was still sparse. Fully herbivorous species evolved differently. Their necks lengthened, their teeth adapted to chewing soft leaves, and their bellies grew larger to digest cellulose. All these traits made dinosaurs perfectly suited for a changing world. The world shaped by the canyon rain. As the environment recovered and small animal prey returned, the earliest carnivorous dinosaurs began to appear and expand their ranges. Herrerasaurus, one of the oldest meat-eating species. It was not large and only about 4 to 5 meters, but it ran very fast and had powerful jaws. Herrerasaurus was a prime example of dinosaur advantages: agility, surprise attacks, and flexible hunting behavior. Eoraptor, smaller but more agile and more intelligent than many reptiles of its time. Eoraptor was an opportunist, omnivorous, hunting insects while also feeding on carrion, helping it survive in a highly unstable environment. Coelophysis, a slender dinosaur about 1 meter tall and nearly 3 meters long, living in herds and running like the wind. The success of Coelophysis lay in its social behavior: group hunting, group nurturing, and coordinated attacks. When large predators declined, Coelophysis exploded in number, spreading across Pangea. These carnivores were not giants, but their small size and agility helped them dominate a world being reborn. Meanwhile, herbivorous dinosaurs could be considered nature's most favored group. Changes in vegetation after the canyon rain gave herbivores a golden opportunity. Soft, thin-stemmed plants that grew rapidly after rains were excellent nutrition for species with large, stable digestive systems. Plateosaurus, one of the icons of the late Triassic, up to 8 to 10 meters long and weighing several tons, yet well-balanced. Plateosaurus had 2 modes of movement: on 4 legs while feeding and standing on 2 legs to reach higher foliage. It was large but still mobile, an important advantage. Massospondylus, able to move on two legs with a small head and long neck. Although not as large as Plateosaurus, it was very agile in the young Triassic forests. Rainstorm, a large quadrupedal herbivore living in small herds. It was well adapted to feeding on shrubs that sprouted after rains and was difficult for small predators to bring down. These species flourished because the new vegetation suited their large bodies. Competition was low after many ancient reptile groups died out, and they could migrate long distances during shifting climates. Herbivores were the foundation that allowed dinosaur populations to boom. When herbivores became abundant, predators grew accordingly. At the end of the Triassic, the world again entered a period of climatic fluctuation, but this time, most large reptile groups could not survive. Ancient amphibians nearly vanished as the environment became increasingly dry and hot. Large pseudosuchians declined because they could not adapt to the cycle of wet, dry, wet again. But dinosaurs were different. They were forged to survive chaos. Light bodies allowed them to adapt well to unstable ground. Advanced respiratory systems helped them endure low oxygen conditions. Straight legs enabled rapid migration to avoid droughts or floods. Dietary diversity meant they were not dependent on any single food source. High reproductive rates allowed their populations to recover faster than most creatures after environmental shocks. No other reptile group possessed this perfect combo, and none were flexible enough to keep adapting continuously for millions of years. As their competitors gradually disappeared, dinosaurs became the only reptile group still thriving, and from there rose to absolute dominance. However, that fragile stability did not last. At the end of the Triassic, around 201 million years ago, another catastrophe struck, destroying much of the flourishing ecosystems. This was the Triassic-Jurassic extinction event, one of the 5 greatest mass extinctions in Earth's history, and a decisive turning point that pushed dinosaurs into an era of total dominance. It all began when Pangea, the massive supercontinent holding all land masses, began to split. Silent but violent geological tremors spread through Earth's crust. In the region that would later become the Atlantic Ocean, deep fissures opened, allowing molten magma to erupt on an unprecedented scale. Scientists call this gigantic volcanic region CAMP. The Central Atlantic Magmatic Province, one of the largest magmatic provinces ever recorded. Lava did not only flow, it erupted in pulses lasting hundreds of thousands of years, covering land areas as large as all of Europe. Each eruption released enormous amounts of ash and toxic gases into the atmosphere. The result was extreme global climate swings strong enough to trigger repeated ecological shocks. CO2 levels skyrocketed, rapidly heating Earth while sulfate from ash reflected sunlight, causing short-term cooling. Temperatures fluctuated unpredictably, hot then cold, preventing many species from adapting in time. Acid rain fell on young forests, weakening vegetation. When forests collapsed, terrestrial food chains faltered. The oceans fared no better. CO2 dissolved into seawater, acidifying the seas and attacking limestone-shelled organisms, corals, and many groups of plankton, the foundation of marine ecosystems. This collapse led to the death of countless fish, marine reptiles, and arthropods in shallow waters. These relentless upheavals created a brutal natural filter. More than 40% of terrestrial species vanished, with the most severe loss being the decline of crocodile morphs, the ancient relatives of crocodiles that once dominated much of the Triassic. They were powerful predators, but their heavy bodies and slow metabolisms made them unable to cope with abrupt climate shifts. Many other reptile lineages, from medium-sized herbivores to large amphibians, were wiped out completely. More than half of all marine reptiles also disappeared. The world suddenly became empty, like a stage cleared overnight. Yet amid this ecological wreckage, dinosaurs survived. And not only survived, they were poised to explode. Why this happened remains debated, but 3 factors are considered most important. First, dinosaurs had exceptionally efficient respiratory systems. Similar to birds, allowing them to withstand low oxygen and violent climate swings better than most reptiles. Second, their upright posture and light bodies let them move quickly, conserve energy, hunt more easily, and migrate when environments shifted. Third, dinosaurs had already begun diversifying, some small and agile, others larger and feeding at different vegetation levels. When the old ecosystems collapsed, this diversity preserved enough branches of dinosaurs to pass through the disaster. The final result was an ecological power shift unlike anything before. All of dinosaurs' strongest competitors, Triassic reptile predators, giant amphibians, and early marine reptiles, declined or vanished. Earth was emptier, but full of new opportunity. And into that void, dinosaurs stepped directly into dominance with no rivals left strong enough to stop them. The Triassic closed like a storm-filled chapter, with the planet tested by harsh climates, mass extinction, and endless geological upheaval. Yet in that brutality, evolution selected the most extraordinary survivors. Dinosaurs were not born to rule. They matured in adversity, adapted under hardship, and rose from the shadows of destruction. The Triassic was the forge that tempered them, transforming small, fragile creatures into the absolute rulers of the land. And when the Triassic ended with yet another catastrophe, only dinosaurs stepped through the gateway into the Jurassic. Their most dangerous competitors erased, ecosystems rebuilt, and the entire planet opening into a new era, an era where dinosaur roars would echo for 135 million years. Their journey from the ashes of the Triassic to the throne of the Jurassic is not merely a story of survival, but a vivid testament to the power of evolution and the resilience of life. If you find this incredible journey captivating and want to explore the next chapters, from the age of the giant sauropods to the golden era of T-Rex, don't forget to like, subscribe, and turn on notifications to avoid missing any videos. Thank you for staying with us until the end. See you in the next adventure.